All right, hey everybody. My name is Adam Williams. I'm the search lead at Iron Mountain. We're a global records management storing company. We have a large Solr implementation we've been working on for the last couple of years. We went to production back in about 2013. Currently we have 6 billion documents stored in about 38 clouds. We're completely virtually hosted. Everything's hosted in ESX servers. We have about 150, actually 180 now, virtual machines running in the environment on a dozen blades or so. We average about 11 million updates per day in our indexing, and we average about 140,000 searches a day. Iron Mountain's kind of a unique business. We do box pickups and file pickups, kind of like FedEx does, but ours don't get shipped anywhere. They just go back to the warehouse to be stored. Or many of you might have us as a provider for your data backup tapes. We rotate the tapes and we store them back in our facility. And when you need a backup, you come to Iron Mountain, and then we send that out to your location. So we get a lot of searches during peak times during the day, like between 9 and 11 in the morning. We'll get 20,000, 30,000 searches just in that period of time alone. We started down this road looking at disaster recovery for our solution. Basically, we have a very large index. We're over 5 billion documents, and none of us really slept real well at night when we first put this thing in production, knowing that it would take us 2 weeks to re-index everything. We're capable of indexing, at over 140,000 documents per minute on our indexers. And even with like a dozen indexers, you still do the math. That's a long time to go and rebuild your index if you ever lost something. And then the challenge is with multiple clouds, what do you go and rebuild? How do you figure out what you had there? So we've started down this route of going and indexing to 2 different clouds, right? One in a backup data center, one in our primary. And we went down that route and we discovered that isn't what we wanted to do. So we started talking about what we needed to do for CDCR here. So our business requirement that was given to us was to maintain a disaster recovery environment capable of being fully functional within 4 hours of an event. That means there was a fire at the data center, there was a flood, right? The data center is completely offline, there's no network connection for a period of time. We go into this disaster recovery mode. And the data accuracy needed to be within 15 minutes of what it was in production. And we settled for doing active-passive with the solution. Ideally, we want to go active-active, and we'll get into that in just a little bit. All right, so disaster recovery. Well, this is the Apple data center there in Arizona. Solar panels caught on fire, and that wasn't a good day for them, right? This can happen to any of our data centers, and we need to be aware of it. All right, so how many folks here actually maintain a full DR system for their Solr clouds? All right, cool. So one of the challenges is looking at the small, medium, and large. If you're a small company, it can be a challenge at times, right? Larger companies usually put more investment into it. They have the infrastructure. They have the ability to maintain it. All right. So with Solr, you have many different options for doing replication, right? You could do the index to 2 different locations, right? You could take the old way of, I'll just rebuild it when it happens. I'll rebuild it from the originating source. You can do disk mirroring. Lots of people use disk mirroring. How many people rely on disk mirroring? Okay. We found we had some challenges with disk mirroring. In disk mirroring, if the application was up and running hot, right, and that backup happened or something was synced, it wasn't guaranteed that index was going to come back up on the DR side, right? We'd look at it and be like, how come this one index file was corrupt? Why isn't it coming up correctly? Really, you have to have things kind of shut down in a static environment with no indexing to be able to have a full cold backup, right? Not a hot backup. And that's the same challenge with backing up, to drives. With our organization, we're always indexing, right? We're constantly getting changes. As the user makes a change to their record, that we store our amount. They can change the metadata at any given point during the day. We index it within 15 minutes of their change. So if those changes are happening throughout the day, we never really have a point where we can take a checkpoint, a true checkpoint, to restore onto a backup. So we came up with the idea of cross-data center replication. We engaged a couple of our open source committers, and we built the cross-data center replication functionality. One of the big advantages of cross-data center replication that I found is that for us, we have a hot standby, right? So I can go to bed at night knowing that the DR environment's there and ready to go. If there is a disaster event, I have very little to do as a search lead. All we have to do is change the VIP entries on our networks, and it's all ready, it's all there to go. We also found that with CDCR, we have a secondary environment where we can go do some more aggressive queries. Sometimes you want to go run that facet that you never really ran in production. You want to go find and data mine some data that if you ran that on the production machine, you might create a footprint that would disrupt the users, right? And your QA or your pre-production environment just doesn't have that data at that moment for you to be able to run that query. So we do rely on our disaster recovery environment to go out and run some of those queries at times. All right, so one of the things I really like about CDCR is that you can control it as an engineer. You don't have to have a whole group of support people. You don't have to have a whole group of infrastructure, disk, maintenance, network folks who are there to help you out. You really can run it all once it's all set up as an engineer. That gives you more control over it. One of the things we found is that our disaster recovery environment actually would go down throughout the day or in different times of the week. You know, someone would decide to change a switch there, or someone decided that they needed to do some maintenance, and they said, oh, it's just the DR environment. But if we were syncing through disk replication, we'd be running into issues. So now we have a procedure where if there's any maintenance done at the DR center or something happens there, we can just issue a stop command to CDCR, and it just stops replicating. It queues up the log files, and then when we want to turn it back on, we can turn it back on. CDCR also is fault tolerant, where if it experiences a disconnect to your target, your disaster recovery environment, that it'll detect that, queue up the log files, and wait to send them after a period of time. All right, so backing up to Solr, and we've all experienced that, right? Everyone knows that screen. What happened to my index, I don't know. I have a bad index file. Now I need to go run that weird check index script to go find the bad segment. Anyone have to do that before? One guy here, you've experienced it. So we actually had a situation in production where we mysteriously lost some data. It must have been to some latency on the drives, and we ended up with a corrupt index file just like that. And we actually had a great advantage here because of the CDCR being actively running to our disaster recovery environment. We were just able to shut down the DR environment, sync over the index files to the production environment, and we were up and running within an hour. So having the hot standby is always, really important so that you can kind of recover and you have an array of options that you can work through. All right, so what is CDCR? How does it work? So with CDCR, you have your source and you have your target, and it's the leaders trade the updates and the crates that are sent in back to the target environment. So in the target system, it's receiving the updates as they come through and processing them. There's two things at play here. One's called the replicator, and the other one is called the update log synchronization. And when you dig deeper into the CDCR code, you'll see those two pieces. There's a batch thread that's running in the background. So these changes are only synced over to the DR environment after they've been persisted to disk, right? So they're persisted to disk in the source environment, and then they're sent over to the target. Well, I bet you're kind of thinking now, what's that time lag, right? Because everyone wants things to be really quick, and they want to see that update. In our environment with our settings, we see things run about 3 to 5 minutes of latency. And for us, that's okay, right? That's our SLA that we were given was to be within 15 minutes of production. So at any given point during the day, our DR environment may be slightly off from our production environment. But if you go onto the server at a very static time in the middle of the night where there's no indexing happening, the counts are going to be matching perfectly. So we have this batch process. It's configurable, and we'll get into that in just a minute. All right. So when we were looking at how we work with CDCR, a couple of things came to mind about what we need to look at. When you go look at the CDCR API, there's a bunch of different commands out there that we give. There's the ops command, there's the start-stop command, there's a queues command. We've built out a whole API that allows you to be able to evaluate what is out there for CDCR at that given moment. So we have the ability to, with the CDCR API, if you go look it up on the Apache wiki pages for Solr, you can issue a start command, you can issue a stop command, you can issue an ops to tell you where and how many T-logs are backed up in the system, how many need to be run, and you can go through and pull up different stats. So one of the things that we ran into in our considerations was looking at the disk size. So when you're pulling in all these different updates, you're going to need to have more disk, right, to store the updates as they're queued and sent over. In particular, you need it for when there is an outage or a disconnect to your DR system where you need to queue up the records for a period of time before they're pushed over. So we created a separate partition for our T-logs directory, and we put monitors in place on that to make sure that when something happens, we're alerted. We allow the disk to grow to about 60% full before someone's notified, and then they'll go in and look and say, okay, what's going on with CDCR? Connectivity to the target zookeeper. So a lot of people I've heard have tried CDCR and never could get it off the ground. In fact, someone said that right when we were coming up. So how do you get it off the ground? It's really simple. On your startup commands, like let's say you're running in Tomcat or you're running in Jetty, in your Bootstrap, you're going to be giving it the target ZKs. So what happens here? You have the primary system, which is running its regular ZK host. Everyone knows ZK host, right? You add a different parameter called the target ZK. So these Solr clouds in your primary environment are only aware of Zookeeper through this command to see the target zookeeper. So you're going to have a zookeeper in your production environment and a zookeeper in your disaster recovery environment, right? And you sync between the shards once you discover your disaster recovery cloud. So it works like this. The Solr cloud makes a call to the target ZK and says, do you have this cloud in your collections in the DR system, right? It responds back with the cluster state for that given cloud, and then you can then connect directly from one Solr instance to another where we're replicating. So the connectivity to target zookeepers, you have to have a good connection to your target zookeepers. If you don't have that, you're going to run into some issues, right? It's heart beating with the targets just like it is with your source, your original data center. All right. Secondly is CDCR enabled. So in these API commands I was talking about, we have the ability to stop and start CDCR. Really, all you have to do is the first time, put in the start command, and it should work. And if you want to know if it's running, you can run the status command, and it will tell you if the process has started and what the buffers are in. We'll talk about buffers in a minute. But one thing that we found as a best practice is that we always issue the stop and the start on a deployment. We just found that we weren't always sure if that start had been in effect by default. So we use Puppet for our deployment processes, and as a part of the Puppet process, we always issue a stop and a start after we do a deployment. What's really important here too is disabling the buffers. So when we're doing CDCR replication, it's buffering more and more data. And for the update log to go and clean out that data on the target, we have to have the disable buffer command in there. Disable buffer will make sure those T-logs stay down to a low number. Without it, you'll end up with thousands of T-logs before you know it that are waiting to be cleaned up. And this is what we found, is to always issue the stable buffer on our target system. So to validate that CDCR is working end-to-end, what we do is we put a sample document, like a test document, into the production environment every like 10 minutes in production. And then we wait and sync and see how long it took to run over to our DR environment. We use a combination of tools. We use Nagios, we use some custom scripts, and we use a product called Solr Winds. Nagios works great. The custom scripts work great. But what we do here is we're always making sure that that environment is in sync with each other. And by sending in that sample document and then searching for it, 5 minutes later in the disaster recovery environment, we can then send an alert out if it didn't sync in time. All right, determining the queue size. So the T-log size is something important to monitor. So by putting the queues option into your API statement, you can get back what the total count is, how many are out there, and what's important is the last timestamp. So every time the CDCR runs a batch, right, it knows the last date and timestamp of that batch. All right, performance. There's a command you can put in here that's called the ops command. The ops command will tell you how many records are being synced per second, per second, what your per second throughput is. So by issuing the ops command, you can find out for the duration of time that that Solr instance has been up and running, what its throughput's been. And this is what we use to monitor our performance as a key indicator. So a lot of people say, like when you go to set up CDCR, there's the scheduler, and there's also a couple other options in your Solr config. In the Solr config, it has to set what is the total batch size? How many do you want per batch? How many records should run before, and how long should that schedule run for? So if you only get 100 updates within 10 seconds, go ahead and send them over. So we have all those settings in the Solr config, but by using the ops command, you can determine what your throughput is. Is your throughput sufficient for your settings? And that's what we rely on a lot for the testing. All right. So I had the misfortune of the PowerPoint deck that I had put together wasn't the one that was put up here. So I had to run through that. So what's CDCR? Does anyone have any questions about how CDCR works and what about the settings and options that you need to put in? Good. Yeah. Well, if I have my other presentation, which will be available online, I had a slide in there for that. Basically, what we have set up for Solr today in our environment is we're doing 2,000 updates per cycle, and we're able to stay up and stay up with our 11 million indexing per day. Our latency that we see is no greater than 5 minutes during that period of time. So we have had a lot of success with large throughput. We're keeping up with our 11 million changes, having 100,000 changes in an hour type deal. We're able to keep up with that. To 100 million, you would have the latency, right? It's batching up and working through those updates. Now there is an option on the Solr config where you can set the number of threads that you want it to run in. I think the default is 2 threads. We have ours set to 10, right? So by running at 10 threads, we get more processing. One thing that we were really conscious of when we put CDCR in place was we didn't want to increase our memory footprint, and we didn't want to increase the CPU, because we put a lot of effort into our VMs and making sure that they were structured just the way we wanted them. So we actually were able to work with those settings to stay with the same memory footprint and same CPU footprint. But if you needed to have that additional capacity, you're going to look at more resources for that. Question? How different is this? Well, let's see. So when you look at, we have really defined the target and the source systems. And the target and source systems are really not linked together in any way. Now, when you go do replication between master-slave, you're fine. But here in this instance, with the cloud arrangement, we have a full Zookeeper stack in our DR environment, right? So we have 5 Zookeepers in production. We have 5 Zookeepers in DR. If you're looking at adding like another slave or another replica across the wire to your DR system, you're now dependent upon that Zookeeper instance in your production system, right? And then you have this latency of a replica talking to its leader who's in a different data center. So this is really focused to make sure that it's disconnected between the data centers and you don't run into those latency issues between the target and the source systems. Okay? Question? That's a really good point. So our disaster recovery environment, our DR system, the target, is an exact mirror of our production environment. That's so that when we have a DR environment, it works exactly the same. Now, does it have to be? No. But ideally, it should be. If you're going to have your disaster recovery environment, it needs to be a mirror of your production. And that's really important because one thing that we ran into with our virtual machine infrastructure is we found that the guys who are maintaining our virtual machines said, oh, they only need 5 blades in the DR environment, but they need 16 in production because we don't see the traffic in the DR. But you know what happens? As soon as that DR system were to be activated, it would just fall over, right? You'd blow out, those ESX servers over to 90%. They'd be V-motioning all over the place, and you'd hit a brick wall. So I really recommend that DR is an exact replica of your production. Where our data center is located. We have Iron Mountain. I don't know if you've ever seen us on TV. We have a big mine outside of Pittsburgh that's in an old coal mine down in the basement. And it's a data center that's supposedly nuclear bomb-proof, right? And then we have our remote data centers out in Kansas City. So we have the 2 data centers in completely different geographic locations. What's the network latency? So the network latency, so this is really interesting. I was really worried when we first put this in place because the same pipe that we're using for the networks is also used by our databases to do exactly the same thing. Our databases are Oracle, and we have a couple other databases running. They're doing the same mechanism over this wire. And we actually have an agreement worked out with our service provider where we have a scalable network pipe between there. So we can scale up and scale down. As soon as we hit a point where we're sending more bits per second than the pipe can handle, it actually auto-extends. So we have an auto-extend between these 2 data centers that just keeps on adding more and more bandwidth as it comes through. I don't know exactly off the top of my head, no. One thing that's really important that I didn't cover is when you go to roll this out for the first time, you have a challenge. Let's say that you're already in production for a year, and you already have an index that's 5.3 billion like we have. When we went to go roll it out, we had to come up with a plan to get the current indexes over to the DR system, because what does CDCR do? It's only going to take the deltas from that point forward over to the DR side. So what we did is we took, we have weekly outages for hotfixes, and so we have 38 clouds. So over a period of a couple hotfixes, every hotfix we'd shut down the production environment for a couple minutes, and we would rsync, just using the rsync command, the index files for that cloud over to the DR, and then turn it on, and we turn on CDCR for that cloud. And we did it cloud by cloud. So that's really important. So when you go to do this, you can't just go and say, I'm going to magically turn on CDCR if you have an existing index. If you don't have an existing index, it's real easy. Just turn it on, and as it gets and grows, it'll get copied over. Yeah, you would, yeah. Correct. Question? This is the CDCR implementation is under a JIRA number. If you download my presentation, it's going to be in that version. There's a JIRA number out there that we did, and it's in Solr 6. So in Solr 6, the new feature for CDCR is there. It's all documented out on the Solr wiki. You just Google it, it comes right up. It's a part of the Solr 6 implementation. Now, we're kind of a unique situation. We're running Solr 4 in production. I want to get Solr 6 out there, but we aren't quite there yet. We have that running in our development environments, but haven't promoted it to production. So we did a backport. We worked with several Solr committers, and we backported to version 4.6. And as we move forward to 6 now, we'll be able to take advantage of any updates and bug fixes. Second? So yeah, so that's where we want to go with this. So long term, how can we take these changes we made to the CDCR replicator and turn that into an active-active scenario? We have a really unique situation, which I think probably a lot of other people have run into, where are you starting to see some data centers say that they only want to see data housed in that country, right? Everyone hear about in Germany, Canada, everyone running into that. We're starting to explore the solution to see how we can do some data syncing between the data centers for data that's common to all of our regions and markets, but then to keep some of that data separate in each of the markets and store it separately. That's something we're experimenting with, is the idea of being able to sync that common data. Like for us, the customer name is not something that you have to protect, right? But the details of what's in that metadata around that box or file that Iron Mountain stores, we need to protect that. So we're looking at how we can do active-active in scenarios like that. Plus, when DR goes down, we are kind of in an interesting position. If we went to DR and ran in our disaster recovery environment for a week, well, then how do we get production back, right? And so the challenge there is that's kind of a black hole. Like, we've solved one problem. The problem is we can handle disaster recovery environment. But to get your production back, you're going to have to re-index it or copy that back over to your production. Again, CDCR gives us an array of options to do that. You have to get a little bit thrifty with then working it in that scenario. Got yeah. Oh, we run the same time in all of our data centers. We make sure they're all running the same. But this is the timestamp that's given there is what the JVM has. So JVM has that timestamp in working with the Solr implementation. It knows that timestamp, and that timestamp is used for each of the update logs. So yeah, we are very dependent upon the timestamps that are given there. And that's one of our indicators that if CDCR has latency, if that last update was, hours ago, that's an indicator that we're starting to experience some issue, right, where things aren't syncing through. The DR system does read the timestamp, yeah. Question? Yeah, actually, we haven't tried that. That's something that, so part of this is what can the community do with CDCR from this point forward, right? This is one of the things that's actually available there. So you can have multiple targets in the implementation. So you could say, I actually have 2 backup data centers, right? And you could sync to both of them. Or you can spread this data between markets and regions by using a CDCR approach. No, well, we haven't gone down the active-active path. Currently, the code only supports the active-passive. We believe that we've laid the groundwork for active-active. And that's something we're looking for. We like to get a JIRA ticket in for that and start exploring active. We've talked to a couple other companies that we work with who are actually very interested in that in their Solr implementations. Yeah. So soft commits are not going to be synced over. It's only on that hard commit where it's persisted to disk. So we have our hard commits set. We actually hard commit rather frequently. And our hard commits, when that happens, it gets written to the disk and they get written over. But your soft commits, you're not going to have that data syncing. It's only on the hard commit. Question? Yeah, so if we fail over during a period of high indexing, so let's see. So we have a couple things with indexing at play here. One is that if the DR environment were to go down, so this is a different scenario where the DR isn't available, we make sure that we turn off the indexing after a period of time because you're just going to keep building those disks up until they're completely full. So we have a procedure in place where we shut down the indexers when there's a type of event like that. Now, when we're syncing over to DR with the indexing, we are expecting that we will have some data loss, right? And we're not too worried about that. We know that there's going to be a gap of a couple minutes of data between our source and our target when we fail over. Now, we have the ability to index on the fly in our disaster recovery environment. At that point, we're assuming that we're going to do checks to see where we may have data missing. We have the ability to go check the number of documents per customer. We can run that report and within a couple hours adjust for that missing data, right? But that is a risk you run. If you have a high volume of indexing and this thing suddenly cuts out, yeah, you may have a couple minutes of data loss, but it's better than having nothing, right? And for us, we can justify that difference because we're not the system of source, right? Our databases are, and we can discover those changes and reindex them. Yeah, go ahead. Can we send, yeah, you can. You can update the target directly. The only problem is it's not going to make it back to the source, right? Go ahead. No, we haven't, no. I'm not sure if I completely understand. What was the question? Yeah. Oh, yeah, yeah. Yeah, if you create a new index there, it's not going to get sourced right over there. Well, CDCR is on at the moment, yes, it will. But you have to add into your startup commands the name of that collection. So it's the only thing. You'd have to bounce the instance. So on the instance, there's two parameters you're passing in. One is the ZK host, the target ZK host, and the other one is the target source. So you have source collection, target source, and ZK host on your startup. So your source collection and your target collection, they don't have to match. It could be Cloud A and Cloud B, right? Ours match because we want to be consistent between our two environments. We have Cloud 1, right? But you can add in additional collections, but they'd have to be in the Solr config, right? And we happen to override those on our startup commands. So you'd have to put in your Solr config into Zookeeper and bounce. Yeah. Yeah. Online. And that's a type of enhancement that we could look to do that should be considered. We literally designed this for our needs at the moment, and we thought about the greater needs of the community, but requirements like that are awesome. Those are things that could get put in, the ability to discover those on the fly. I mean, we already have the connection there to Zookeeper. Why can't it go and find it from Zookeeper and do it itself? Right now, we're just relying upon it being hard-coded, essentially, in the Solr config. But you could get out of that, and we could have Zookeeper discover it and provide that back to the classes. I'm sorry? Can the target reference? No, we don't have that built in for the target reference to be an alias. No. Good. Yes. Yeah. Yeah, in the CDCR documentation, it actually does call out why we did a batch versus a stream. The batch was to make sure that we would have kind of checkpoints and know when our last sync happened. And if that sync happened to fail on the next one, we know where we stopped. So we put a whole section in the documentation explaining why the batch and why we use the batch settings. Because at any given point, the 2 connections could go down. You could lose that connection. We're highly dependent upon that connection, just like you are to Zookeeper. But we're highly dependent upon these 2 connections in between the data centers. And we wanted to make sure we had those checkpoints and timestamps for when the last one happened instead of just continuously streaming. All right, one more question. So so the question is, why don't we just index the 2 locations? Well, we started writing that code. So I have a team of like 20 folks, and we started writing that code. And before we knew it, we had written a lot of code, right? And we were writing a lot more code until I finally said, you know what, I've dealt with database systems for years. And we just do replication in database engines. We don't write code, right? Why shouldn't Solr have a solution like that as well? So the disadvantage to doing indexing to 2 locations is, one, you're not guaranteed that both data centers will have an exact replica. You're not guaranteed, right? You have a better chance when you're doing direct syncing between the systems. Secondly, we were just writing a lot more code because we have 11 million updates we're doing per day, right? And we struggled so much just to get to the point where we could do, what are we doing? 100,000 per minute on updates, right? Our indexer code is just really, really designed to be highly performant. And as soon as we went in there and said, well, then what point do we batch these up and send them over to the DR system, we started then, having to go back and revisit all of our indexing code and then go enhance that more and then be back to the point where we're doing 8,000 per minute, only to go back to 120,000 at some point. So we really decided we didn't want to go down that route. And honestly, our development team had better things to go work on, and we wanted to get on new features, and we said, let's go put this into Solr, just like you do with other applications, with the data syncing happening on the back end, and we don't have to write code or maintain code to do this. And that's why it's back in Solr 6, so that the community can maintain it, enhance it, put different features in, and then we can benefit from it as it goes forward. All right, well, thank you very much.